Hello students, I am Dr. Sadhana, Assistant Professor of Physics, St.Joseph College of Arts and Science, Cuddalore. In this video, we are going to discuss a problem related to basic formalism, that is the commutation algebra in quantum mechanics. Here is a very small problem. Prove that for two operators A and B, e power a b e power a equal to b plus commutation a comma b plus 1 by 2 factorial commutation a comma commutation a comma b plus 1 by 3 factorial commutation a comma commutation a comma commutation a comma b. So now let us solve this equation by considering this left hand side e power a b e power a with the parameter. It may be any parameter, constant or an arbitrary constant, lambda may be multiplied with the component a, operator a. Let us consider this as f of lambda equal to e power lambda a b e power minus lambda a. First, we'll take lambda equal to 0, then it becomes f of 0 equal to e power 0 into a b e power minus 0 into a. So we know e power 0 is equal to 1. So it becomes b. F of naught is equal to b. After obtaining the value of f of lambda equal to 0 as b, now let us differentiate the f of lambda with respect to lambda. df by d lambda is equal to, so it is of the form e power ax. So differentiating e power ax will give you a e power ax. Similarly, differentiating e power minus ax will give you minus a e power minus ax. So now using that formula, we can differentiate df by d lambda as a e power lambda a b e power minus lambda a plus e power lambda a b e power minus lambda a into a. So now again rearranging this equation, it becomes a e power lambda a b e power minus lambda a minus e power lambda a b e power minus lambda a. So here e power lambda a b e power minus lambda a is nothing but f of lambda. So substituting that value, it becomes a f of lambda minus f of lambda a. So again we know the commutation formula. So you know what is the meaning for commutation. So commutation means what are all the values that can be measured simultaneously. Here a, if it is measured simultaneously, the commutation becomes a 0. That is, commutation of a comma b is equal to ab minus ba is equal to 0. So here ab minus ba, it is of the form a f of lambda minus f of lambda a. So we can write it in the commutation, within the commutation as commutation a comma f of lambda. And therefore applying the value of lambda as 0 in df by d lambda, it becomes a comma f of 0 is equal to a comma b, since f of 0 is equal to b. Similar to that of df by d lambda, we can find d square f by d lambda as d by d lambda of df by d lambda. So df by d lambda, we have already found that a comma f of lambda. So again differentiating that one, we can get a comma df lambda by d lambda. Again substituting the value of df lambda by d lambda, it becomes a commutation of a comma commutation of a comma f of lambda. And at lambda is equal to 0, d square f by d lambda square becomes a comma f of 0. Therefore, that it becomes a commutation a comma b. Similarly, we can find the value of d cube f by d lambda cube at lambda equal to 0 as commutation A, commutation A, commutation A, B. So expanding the f of lambda as power series using Taylor series, we get f of lambda is equal to f of 0 plus lambda by 1 factorial into df by d lambda at lambda equal to 0 plus lambda square by 2 factorial into d square f by d lambda square into at lambda is equal to 0 plus lambda cube by 3 factorial into d cube f by d lambda cube at lambda equal to 0 plus etc. Substituting the value of f of lambda, f of 0, df by d lambda at lambda equal to 0, d square f by d lambda square at lambda equal to 0, and d cube f by d lambda cube at lambda equal to 0, we get the values as, after substituting the values of f of naught, df by d lambda at lambda equal to 0, and d square f by d lambda square at lambda equal to 0, d cube by d lambda at lambda equal to 0, we get e power lambda a b e power minus lambda a is equal to b plus lambda by 1 factorial into a comma b, commutation a comma b, which is the value of df by d lambda at lambda equal to 0, plus lambda square by 2 factorial, commutation of a comma, commutation a comma b, which is the value of d square f by d lambda square at lambda equal to 0, plus lambda cube by 3 factorial into commutation A, commutation A, commutation A comma B, which is the value of d cube f by d lambda cube at lambda equal to 0. Now let us substitute the value of lambda as 1. We get e power lambda a b e power minus lambda a as b plus, since lambda equal to 1, it becomes 1. 1 by 1 factorial becomes 1. So it becomes a comma b plus 1 by 2 factorial, lambda square also 1. So 1 by 2 factorial into a comma b plus 1 by 3 factorial, commutation of a comma, commutation a comma, commutation a comma b, which is equivalent to the proof given in the question. Hence it is proved. Thank you for listening. Thank you.